Welcome to the next talk. This talk is by Ulf Herman about analyzing CPU usage. And I think he's the only one in the whole schedule who got 1 minute more for its talk.
Yeah,
okay.
Unfortunately it's not November 11th today. Well, I'm happy to hear that you're all here. It's very nice to see you all. I'm Ulf Herman, and I've been working on analyzing CPU usage and profiling, and also on the QML Java and JavaScript memory profiler and stuff since 2013 for the Qt company. And today I'm going to present my new project. It's a profiler for embedded Linux systems. Especially comes with our Qt for device creation offering. And yeah, I'm not going to spell out that name all the time. I'm just going to call it Perf Profiler, P-E-R-F. That's the utility it uses. So don't be irritated by that. So I'm first going to talk about what it does and how it looks like, and then the most part of the presentation will actually be showing it live in action. So I have this little device here. It's an IMX6, and I'll run a little application there and optimize it. And yeah. So whenever you have any questions, just ask. And yeah, then I would start. Any questions up front? Okay. So, if you have used QtCreator 3.5, you might have noticed the new entry in the Analyze menu. That's a CPU usage analyzer. That's exactly what I'm going to talk about. And as I said, it works with Qt for device creation. It also works in desktop Linux, incidentally, which is quite practical for some things. It's included in the commercial QtCreator from version 3.5. There are some important improvements in the upcoming version 3.6, though. And it's based on Perf, as I said, and Perf is a tool that I use in this case for periodic sampling. That means that every X milliseconds it stops the program and takes a sample of the stack, and then you can later aggregate those samples and do some statistics on them. But it won't catch every function call. So if the samples are far enough apart, you will miss some function calls, and if they're close together, you may see some function multiple times, and basically that's how it works. In contrast to, for example, valgrind, that just emulates the whole code and catches every function and exactly how long it runs. However, the sampling approach is very fast and doesn't result in so much overhead as the emulation approach. And so you can run it on those little devices and get a realistic profile of what your application is doing on them. So how does it work? Well, as I said, Perf utility in its original environment, you use it to record a trace with Perf record, and then you can use Perf report to show the trace in a nice text interface, which is okay in itself, but it has a couple drawbacks. That is, the text interface is not really approachable for the average user. It takes some time getting used to it. And it looks for the debug symbols and libraries the application uses in the exact same places as it has found them when perf record was done. So you basically have to do it on the same machine that you did perf record, or you have to do some really intricate setup, and it also only works on the same CPU architecture, so you cannot record something on ARM and report it on x86. So what I did is I used the record function to generate the trace, and the trace is sent in real time to the host system, where I analyze it myself with QtCreator, and I do all the heavy lifting, like unwinding of the stacks and finding the symbols and so on in QtCreator, or rather in a little helper application that QtCreator uses. And that results in faster execution time, so you don't need to wait for the report to be generated. And you can do it across CPU architectures. And then you can generate nice graphical representations. If that reminds you of the QML Profiler, you're right. I'm basically using the same timeline library I'm using there. So what you see there, where's the mouse pointer? Yeah, it's basically a thread. And you don't need to see all the details here. It's just to give you an idea. And the stack is growing from top to bottom. And down here, you see like the interesting part, what it's really doing. And yeah, you can, as you're used from the QML Profiler, if you use that, you can filter that and sort and zoom, and you get an overview to see, spot the hot regions. And it shows you the places with a lot of samples in a short time frame as bright colors, and the ones with fewer samples as less bright colors. And that's because the Linux kernel only collects a sample if the application is actually using CPU time. So you can derive from that where actually the regions are that used a lot of CPU time. If the application doesn't use any CPU time, like you can see here in this like upper thread where it's like all brown and grayish, then there are not many samples. And with QtCreator 3.6, you also get a statistics view where you can see how many samples were caught with which function and so on. And again, you can sort and filter that, and you can walk through the recursion. And yeah, you will see that in a minute, because now I'm going to do the live demonstration. Just a second. So I have this little program here. Basically, I'll run it on the host computer to show you what it does. And later on, I'm going to run it on the little device, but you don't need to really see what it does on the little device, because it does just the same thing. It's mostly for me to check when it's done. And we're going to check how long it takes. Like I ran it before, and you can see here it took like 3 seconds to do its job. So let's see what it does. So I have a desktop configuration and a device configuration here. And I'm just going to run it on the desktop now. So the application takes a couple pictures from a standard location, scales them to little squares, and draws a sort of a histogram on each picture where it analyzes how often which color occurs. And if you look at the output, on the desktop it takes only 850 milliseconds, so that's probably acceptable. But on the device, let's run it on the device. Yeah, it's still running, it's still running, it's still running, and it took 3 seconds. So let's see if we can improve that. Let's just run it through the CPU usage analyzer. So what did I do? I went to analyze mode, and already before I chose CPU usage analyzer from this drop-down here. And there are some important configurations you have to apply. Actually, one. You have to check generate separate debug info here. And you want to do that on a release build, because otherwise you won't get a realistic profile. That's really important, because otherwise it won't find debug symbols, and then it won't show you any function names, which is somewhat inconvenient. But let's go ahead and run it. Oh, that was the desktop configuration. Not very interesting. This is what I wanted to do. So now it's running. And you see those two numbers running here. One is the time that it has already recorded, like the samples it has already processed and the time frame covered with those. And the other one is the time between the last frame, the last stack it got, and the current time. So if an application stops generating any data, this just keeps running. But you can always stop it. And then you get this nice profile. And this is not a particularly long profile, so we can just look at all of it at the same time. And you see here, this is the main thread. There are a lot of samples in the front and then hardly any in the back. And that is because I'm using a couple worker threads to do the actual work. So here's one. And this thread, so this is probably start thread here. So this, yeah, in fact. And it calls a couple functions, probably runs through the usual threading, Qt concurrent stuff, and then the interesting thing starts down here. This is basically the function that runs all the time. You see there are some little interruptions here. This is places where it cannot unwind the stack because those are highly optimized assembler constructs which just don't really follow the calling convention. So you see that process function, and from that process function, you see a couple other functions it calls. So now again, don't trust the exact boundaries of those blocks here. It could be multiple calls wrapped into one because of the sampling approach. But it gives you a pretty good picture of what is approximately happening this timeline. So the most important thing is obviously this draw color profile function. Now let's see what that does. Conveniently, the click already scrolled us to the right place in the editor. So this draw color profile function is, if you remember, this is what draws the little histograms of the pictures. It first fills a couple arrays with the zeros here, and then it goes through every pixel in the picture and calculates its red, green, and blue value and fills that into the arrays, and then it paints a line according to this number it found there on the picture. Now, if we look at the statistics of the draw color profile function, first you have those occurrences number. This is how many samples contain that function in total. And then the next interesting thing is the self number. Self number is how often was that function on the top of the stack actually, and hadn't any other functions called. I'm gonna speed up this a bit. You see the draw color profile function is only called from process, but it does call a couple other functions. Here, this is the callee view. And most prominently, it draws the constructor of QColor. It calls the constructor of QColor 43% of its own time, which is quite a lot for just a constructor. So let's see if we can do something about that. There's exactly one place where it actually constructs a QColor, and that is here. That is basically in the inner loop when it finds out the color of that pixel. And we can improve on that because we don't really need a QColor here. What this image pixel spits out is QRGB, and that's entirely enough to get the red, green, and blue values for that pixel. And so we're going to use that. We're going to use that and see if it gets faster. There are those nice inlined QRed, QBlue, QGreen functions that we can use.
Typo in line 125, red instead of reg.
Oops, thank you. Now before we run this, let's go back to the profile and note a couple of things. So it took 3.1 seconds, but there is a lot of noise in the profile. There's a startup code which has an influence on the total time, and there's it probably depends on how the pictures are split up among the threads and so on. So if we only have a small difference, which I predict we will have here, we won't really see it in the total time, unless we run it 100 times, which we cannot do here, which you should do, of course, to prove such things. So I'm gonna take a little shortcut here. I'm only gonna look at the relative time the draw color profile function took in process. So if we only modify the draw color profile function, and then its relative percentage of process, which is the whole image processing, including loading and scaling the image, goes down, then we have achieved something. But okay, let's run this again. It's still running, it's still running. Now it outputs something. Oh, 2.5. That's better than I thought. Yeah, you see there's a certain random factor in there. You should, if you're really trying to prove that it's better, you should run it multiple times. So let's go looking for that function again. So this is yeah, exactly what we are looking for. And if we check the relative, then it's 78%. Yeah. So what happened? It's not really gotten much better. Of course, those function calls to QRed, QGreen, QBlue have a cost by themselves, which is a bit higher than just asking the QColor for a respective number. So it's hardly improved things. But if we look at the function now, we see that it doesn't produce any QColor constructor anymore, and basically spends most of its time just in itself without calling any function. And this is interesting news. Now, if we look at what it actually does, you see it iterates the pixels first by X value and then by Y value. So in fact, what it does is it goes through. So the question was if there's something for Windows embedded. Right now there's not. This is specific for the perf utility that exists on Linux. However, one could write something similar for Windows embedded. It's like not such a big step if there's a infrastructure for profiling Windows, which I cannot really say anything about. Yeah, you could use a what's it called on macOS? There's something similar to perf. You could use that and to write a converter that converts it the same format that the perf parser spits out, and would work. Yeah. So the question was if it's also possible to use this in the LGPL version of QtCreator. Unfortunately not. You need a license. You can of course use perf yourself and use the text interface that comes with perf. But yeah. Yes, in front.
Okay. First of all, thank you. It's your first night.
Okay. So the question the question is if I unwind it on the host. Yes, I unwind the call stacks on the host. The second question is why do I need to pass it to use the dwarf mode? I need to use the dwarf mode because on ARM there's no clear convention on frame pointers, and also all the Qt libraries are compiled without frame pointers, so it would be like a big overhead to fix this. And basically the Linux kernel doesn't understand any of the frame pointer conventions that GCC can generate, at least not the Linux kernel as I was working with here half a year ago, and so I just opted for dwarf, which has a higher overhead. Like it takes a snapshot of the whole of the stack all the time, but it at least works.
Okay, great.
Yes?
If this is used underneath this tool, if it's using that Linux utility, does this work on regular Windows desktop?
The question was if it works on Windows desktop. Now, right now it doesn't work on Windows desktop. But we are probably going to make it work with our Qt for device creation for Windows offering if you run the actual application on the Linux device. But that's not finished yet, so I can't give a time frame for that. Yes?
Can it be used for multi-core analysis?
If it can be used for multi-core analysis, yes, it can. If you look at the timeline here, you see all the threads are shown as separate entities, and you can see by the shading of the colors which threads are active, and you can even filter the threads. I can say, okay, I'm not interested in the main thread, and I'm not interested in this whatever thread, and I actually only want one of those worker threads. And the statistics view will adapt to that. So now I have a statistic only of one worker thread. And you can also choose a range here and say, okay, I'm only interested in that range, so limit the statistics to that range. There's a range with 5 samples or so, so this is gotta be a really short, yeah, you see? Statistics. Any further questions? Okay.